Am I audible? Am I audible? Please confirm. Am I audible? Okay, let's start week 4. Uh, it is This is the week 4 discussion class, doubt clearance and discussion class. Today I will explain with you the week 3 problem. Today I will explain with you the week 3 problem, uh, uh, week 3 problem sheets and some other problem regarding both week 3 and week 4. So let's start with week 4 problem. This is the week 3 assignment problem I am starting with. So the first problem, as per our records, uh, consider a radical polymerization reaction was initiated by the following species. A radical polymerization a radical polymerization which is initiated by radical polymerization which is initiated by the following species, that is H2O2 plus Fe2 plus, and this is called AIBN, and this the initiator, thermal initiation. So what option is correct? Photochemical initiation, initiation by ionizing reaction. If it is a photochemical reaction, first one, then it should be here H nu. Here is no H nu is there, so it is not a photochemical reaction. The first option is wrong. Next the second one is, just a second. Okay. Next the second one is, hmm, second one is thermal initiation, and second one is thermal initiation and redox reaction. Thermal initiation, the first one can't be a thermal initiation, because if a thermal initiation reaction, there should be heat symbol should be there, and the third option is redox initiator. The first one is, it is a classic example of redox reaction. How? I am showing it how. H2O2 plus Fe2 plus. The structure of H2O2, this hydrogen peroxide, is like this. It can readily break in presence of heat, like this radical. This will form 2OH dot. So 2OH, I can write it like this, OH dot. Now Fe2 plus, the plus 2 oxidation state, then the plus 2 oxidation state, Fe3 plus oxidation state of iron is uh, is much more stable, is much more stable. So iron always, Fe2 plus iron always try to lose an electron and convert to Fe3 plus to get the stability. So if the iron lose the electron, then where should the electron goes? Then we need a medium where iron can lose its electron, where there are some substance that can accept uh, the electron from the iron. So here iron will lose an electron and convert it to Fe3 plus, and it will lose an electron. This I am just showing you for your clarification, but classically the reaction cannot be written like this. So it is the electron that iron has left. So it will combine, this electron will combine one of the OH dot and on the extra electron of OH by the formation of OH minus. So by this reaction we can understood that, so in this reaction we can understood that the reaction will occur like this. Now here Fe2 plus to Fe3 plus, here is the oxidation number of Fe, that is this number. This oxidation number is increased. This oxidation number is increased by the loss of the electron. So when oxidation number increase or the electron losing happens, then that particular reaction is called oxidation reaction. That reaction is called oxidation reaction. And obviously if in a reaction medium one component is oxidized, then there should be another component which is electron taking capability. This is a redox. This is a reduction reaction. So the first one is a classical example of redox initiation reaction. The first one is redox initiation reaction, and the second one is why it is thermal initiation. It's readily can be understood. This is the sign of thermal initiation. This means heat. By giving heat, this N bond will be dissociates and forms N radical. So it is a thermal initiation reaction. So our answer will be answer C. Next problem. This problem, number 1 problem is clear to all of you. Can I move to the second problem? Okay, I am moving to the second problem then. This is the problem, second problem of your problem of your quiz sheet. Styrene was polymerized by heating to 100 degrees centigrade, and this is a self-initiated polymerization. Styrene was taken from 3 different sources. Styrene has to taken from the 3 different sources, 2 of which might contain impurities. Curve 1 is obtained extremely pure styrene, that is the curve 1 is the normal reaction. Curve 2 and curve 3 generated for styrene from the second and third sources respectively. What is the most appropriate nature of impurities in the monomer corresponding to curve 2 and curve 3? So, to understand this problem, we should understand that this is the normal reaction. This is a normal reaction, and this is the we can say that this is a rate of reaction. This portion is the rate of reaction. Conversion by time is the rate of reaction. So when I come to the part 2 curve, we can see that uh, the rate of reaction, the nature of the curve is same, exactly with same with 1, but the rate of reaction, the x axis intercept like this, rate of reaction is decreases. So the molecule which can reduce the rate of reaction is known as retarder, and the second one, in the third curve actually, we can see that until 0.2 at a specific point t, there is no reaction. After that reaction happens, but the rate of the reaction is also very slow. So when no reaction is happen, so this is mean the reaction is inhibited. So this is a case of a inhibitor, and after that, if the reaction follows its normal kinetics, that is the one curve, then we can show that only inhibitor is present. As the rate of the reaction also decreases, so we should tell it a inhibitor plus retarder system. So here your answer C will be the correct option. Okay. Number 3 is the consider monomers of general structure of this. This is a general structure of vinyl bonds. In the following table, select the correct option. That sign, the correct option, plus sign indicates that the monomer can be, and the minus sign indicates that the monomer cannot be polymerized in general by the method of the mention at the top of the column. So if I say CH2 double bond CH and X will be OCH3. Free radical polymerization, okay, free radical polymerization can be happen by the dissociation of one of the bond. Free radical polymerization can be happen, but anionic polymerization, uh, if we say anionic polymerization like this, if one anion is there, we can say partially it can be happen, but it is a very unstable anion because it can be partially can be happen because the negative charge on the carbon atom is stabilized by the oxygen atom minus I effect. So anionic polymerization may be happen, but cationic polymerization cannot be happen as OCH3 is a electron withdrawing group. So carbocation, if the carbocation forms, the carbocation will be very much unstable because OCH3 is a electron withdrawing group. So cationic polymerization cannot be happen. So the first one is wrong. So next option B, if CH2 double bond CH2 it is a phenyl ring, this is nothing but styrene. Styrene, we all know that styrene can be made by free radical polymerization, anionic and cationic both. Why is it so? Free radical polymerization can be readily occur with the dissociation of this bond and forming free radicals. And what about anionic and cationic? As phenyl ring is attached, the phenyl ring shows both plus R and minus R effect, plus R and minus R effect. So when there is negative charge, that is also stabilized by the minus R effect of the phenyl ring, or it is a positive charge, then also it is stabilized by the plus R effect of the phenyl ring. So three of this polymerization can be happen. So next is cyanide. For the cyanide, free radical polymerization can be happen, but anionic is not cannot be happen. And for this group, this is also not right. Our right answer is B. Okay, now it is a problem. It is a numerical problem. The benzoyl peroxide initiated polymerization of monomer follows the simplest kinetic scheme with all the rate constant and F being independent of conversion. For a polymerization system with M0 is equals to 5m and I0 is equal to 10 to the power minus 3 molar, the limiting conversion is P infinity is 30% to increase to P infinity 40%. In what factor I0 should be increased? So we need to know that I0, I0 by, we need to note that IT by I0, I by I0. At what factor? This will give you the factor, this will give you the factor by which you have to increase or decrease the I0 value. So for this we are using for case 1, the formula will be minus ln m by m0 is equals to minus ln 1 minus p. We have this formula that I have discussed in the previous class. So we will consider this formula, up to this we will consider this formula. So for case 1 we can see that for case 1 minus ln 1 minus p infinity 0.3 is equals to 2 kp f kt by kd to the power half I0 0.3 to the power half. Now now it's time to now we will not put the values, we will just write it like this. We will just write it like this and go to the case 2. Like that will be ln 1 minus p infinity for 0.4. This is 2 kp f kt by kt whole to the power half I0 0.4 whole to the power half. Now we want this value, so we will do 2 by 1. We will do 2 by 1. 2 by 1 gives us, just a minute. Okay, 2 by 1 gives us minus of ln 1 minus 0.4 divided by minus of ln 1 minus 0.3 is equals to 2 kp into f. Oh, there is also another term, that is e to the power 1 minus e to the power k dt by 2. We have okay, I will correct it later. Here also, as the reaction condition is independent of the rate constant and the reaction efficiency, so this will be the same. Oh, sorry, this is 0.3 and this is this will cancel out, this is also cancel out. So we will left with minus of ln 0.6 divided by minus of ln 0.7, which will give you I 0.4 by I 0.2 whole to the power half. So ln 0.6, ln 0.6 minus will cancel out. Ln 0.6 will be 0.51. I think it will be minus, and minus 0.356. This will give you I 0.4, I 0.3 whole to the power half, and it will gives you 2.052 is equals to I 0.4 divided by 10 to the power minus 3. This will be and this is also and the value will be I 0.4 is equals to 0020 into 10 to the power minus 3 is equals to 2.00. So it I z so the I0 by I sorry this is not correct. So I 0.4 by I 0.3 is equals to 0.0020 divided by 0.0010. So it will becomes 2.00. So this is the final answer. Is it clear to all of you? Can I move to the next sum? Any question regarding this problem? Okay, then if you have no problems, so I will go to the next problem. This is the problem 5. This actually has discussed in the lecture series. It is a very straightforward question. This is the two polymerization reaction were hampered by the chain transfer following the affirmation mechanism, where the rate constant is related by this. Identify the transfer reaction 1 and 2. So the transfer reaction will be telomerization and retardation. Your options are telomerization, normal chain transfer, retardation, normal chain transfer, telomerization, retardation, and degradation chain transfer, normal chain transfer. This is the telomerization retardation case. It's a very straightforward question. Next, problem 6. Calculate the half-life period. One second. Calculate the half-life time, that is T half, in units of minutes of an initiator in toluene at 70 degrees centigrade, given its dissociation rate constant Kd is equals to 6.93 into 10 to the power minus 3 minute inverse. So we know that the dissociation follows the first order rate kinetics, and according to the first order rate kinetics we have shown in our lecture series and our previous doubt class, that T half is equal to 0.693 divided by 6.93 into 10 to the power minus 3, and it will gives you 100. And you can see the units should be minutes. So how the units can be calculated? Here the unit is minute inverse, and when the minute inverse goes up, it will be minute, 100 minute. So T half will be 100 minute. This is a very easy problem. Next, problem number 7. This is a problem for polymerization thermodynamics. The equilibrium monomer concentration we have to found for the radical polymerization of 1,3-butadiene at 77 degrees centigrade, given that H0 and H0 are supplied. So let's solve this problem. we all know that the Gibbs free energy equation delta G equals to delta H minus T delta S. So, and for this radical polymerization delta T is equals to minus R Tc. Tc is the critical temperature at which the above this the gelling will occur. Ln K is equals to delta H minus T delta S. So, minus ln K is equals to delta H by RT, Tc or T whatever we can write, minus T delta S by RT, Tt cancels out. So, now ln K is equals to minus of ln K is equals to ln of 1 by Me. This formula has discussed in your lecture series and that will also with the same. Now, we have just to put the values 77 into 10 to the power minus 3. In thermodynamics, you should consider the sign. In thermodynamics, there is a very big problem with the sign, and if you have changed the sign, then your entire answer will be different. Here the trick is that what value of R should be put here, because R have many values at many different types of units. So, here see they are given it to you joule. So, we will put the R value in joule, that is 8.314 joule, and T always in thermodynamics T will be in Kelvin. So, just do a quick rough, that is 273 plus 77, this will give you 350 Kelvin. So, here we will put 350 and then minus delta S will be minus 85 divided by, minus should be in bracket, divided by 8.314. So, now minus ln will be plus, how I am showing that, minus ln me to the power minus 1, and for ln it will go to the front and it will be the ln me will be minus 26.46 and plus 10.22, that will be equal to minus 16.236. So, ln me is this. So, for the ln value we have to take the inverse of ln, that is e to the power minus 16.236, and that will give you 8.8 into 10 to the power minus 8. So, let us see which option is correct. The 7B option is correct. This problem is clear. Can I go to the next problem? This problem is clear to all of you. Can I go to the next one? Okay, I am going to the next one. So, for the chain polymerization, okay, thank you for your response. For the chain polymerization of styrene can be associated with the thermodynamic parameters. For all the polymerization reaction, that is the radical polymerization reaction, both delta H and delta S is negative. In polymerization reaction, delta S always be negative, because the degrees of freedom will decrease with the polymerization reaction, because larger molecule is sluggish in nature, their degrees of freedom decreases. So, delta S will always be negative for in any polymerization reaction, and for radical polymerization reaction delta H is also negative, that has discussed in your lecture series. So, here also answer B is correct. So, next is a next sum is a numerical problem. Okay. Methyl methacrylate is polymerized by thermally initiated free radical mechanism at 70 degrees centigrade. The initial monomer and initiator concentration are 1 molar and 0.001 molar respectively. At the polymerization temperature of 70 degree centigrade, the initiator efficiency is 0.60. The rate constant at the polymerization temperature are given below. If the value of the steady state of the free radical concentration after 1 hour from start of the reaction is x into 10 to the power minus 8 molar, then find the value of x. So, I am giving you 3 minutes to solve this problem, because I have discussed this kind of problem in our previous doubt class. You can have you have 3 minutes, and then you can share your answer with chat box, or you can say it in the class. Yes, 1.82. 1.82 is the correct answer. I have also shared my email ID in the chat box, so that if you have any queries regarding your course, regarding your lecture series, or the problems that we have discussed in the doubt clearance classes, you can directly mail it to me, so that if I can help you out. I can try to give the answers. Okay. So, now let us solve this problem, methyl methacrylate. Okay, here the given parameters are T is equals to 70 degree centigrade, I0 is equals to 0.001 and M0 equals to 1. I don't know how many of you can get 1.82 answer, but 1.82 will be come by approximation. Otherwise, if you don't do the approximation, your answer will be something different. So, I am showing you the with the approximation and without the approximation. Okay. Now we have to find out m dot. After 1 hour we have to find out the concentration of the radical, and this is equals to Ri by the classical formula, and this will be F Kt Kd It divided by 2 Kt minus Kdt. Okay. Here I have put the value It is equals to I0 okay. So now let's put the formulas, put the values. So 3600 I put it here for as t time. Time is equals to here 1 hour, and we should keep it in second. So it is 3600 second. And this will give you this will give you 1.66 into 10 to the power minus 8 if we consider It is equals to I0 e to the power minus kT. If we don't consider this
Excuse me, ma'am. Ma'am, I have given this answer only, ma'am, for this 1.66 into 10 to the power minus 8, ma'am. Uh, but the answer, but the answer given that is marked as incorrect, ma'am.
because
Because we,
this kind of technical issues occurring repeatedly, so you have to email to the institute so that they can look into this matter, because it is coming under discussion for the time being. If we consider, if some
yes,
approximation is there, then only 1.8 to will be considered, but the approximation is not mentioned in our problem. So
whom we have to mail, ma'am, regarding this?
Regarding the mail ID, the NPTEL certificate will also be in your email. You can mail
Okay.
in the
Yes, ma'am. Because
certificate.
I have applied based on this formula only, ma'am. For the T, I gave 3,600 and I got this exact answer, ma'am. But in the answer key, they have given 1.80. I think they have considered the T as 0, ma'am.
No, they have considered T as 0. Once you put the T to 0, then the entire term will be IT is equals to 0. Then if you
Yes, ma'am.
consider that is the approximation they are doing. Yeah, this
Yes, ma'am.
if we consider IT is equals to I 0, that is
Yes.
we consider if there's no point of giving the time is 1 hour, then the information should be mentioned in the problem. You should keep mentioning this, and their duration is 1 hour. So if you take IT equals to 0, the answer will come is 1.86 into 10 to the power minus 8.
Yes, ma'am.
Okay.
Yes, ma'am.
You can
Yes.
definitely mail the because unfortunately answer is not in their if you wait for full query, I think they will let you know.
Yes, ma'am. We will mail.
I have tried from my side regarding this explanation, but they told me that only the students can raise query. I can't raise query for them.
Okay, ma'am. We will mail that, ma'am. Similarly, the 10th question answer also, ma'am.
Can you tell if
They've given the answer as 62, ma'am.
yes, one I don't see any concept of any problem 22. Then also what is the answer?
45 it will come, ma'am, but they have given a 62.
Okay, 46 I'm showing. So consider a normally initiated radical polymerization with no chemical reaction and terminated only by a bimolecular reaction between separated radicals. At the end of the reaction, the polymer produce the average number of initiated fragment per molecule per molecule is 1.45. So the polymer produced average number of initiated fragments per molecule, that is 1.45. So the formula is B nu is equals to 2 nu by 2 minus A, that is actually equals to B is equals to 2 by 2 minus A. Then what is A and what is B here? We have to find out A, that is the what is the percentage that is terminated by coupling. This is the percentage that is terminated by coupling, and B is the initiator fragments. So we have to put here B is the initiator fragments is 1.45 and it is 2 by 2 minus A, and it will A is equals to 2 minus 1.37931, and it will be 0.62.
Uh, I have a query. Like, yeah. So, by the sentence average number of initiated fragments per molecule, like suppose if the reaction is initiated by hydrogen peroxide, though, H2O2 will be will break into will disintegrate into OH dot, two OH dot. The polymer growing polymer chain. So by initiator fragments, are we mentioning about the OH dot group in the in the growing
Yes,
polymer molecule, or what, like
if
OH dot? Oh,
if you consider a initiator fragment I dot, then the polymer produce the
hmm?
average number of initiator fragments. This initiator fragment is attached to a polymer chain. and
Hmm.
that molecule, that initiator molecule is 1.45. This is the B is shown. Is it clear?
Okay. Okay. So 1.45. Okay. So 1.45 is the number of so I dot part
I dot
attached to
that
the
is
polymer.
attached with the polymer. That is attached any of the polymer, not the initial number of I dot. It
Okay.
is that I dot that have already
Hmm.
reacted.
Hmm. Okay.
Is it clear now?
Okay. Yeah, can you explain a bit more? Like, if the initiator concentration initially, suppose it is 10 mole per liter. Okay, so so after it get disintegrated into a radical, and then it will attack the monomer, and it will continue to grow in size. So the initiator, so in this case, 1.45 is like the number of initiator fragment.
Maximum number of
Like
initiator
what?
fragments.
Okay, okay. At that time, okay. So it is the fraction, like the initiator concentration at that time divided by original concentration, right?
Let me come to the previous slide where the formula is given. That will be clear for you. 1 minute. Think the formula initiator. Uh, I forgot the slide where should I keep the. You just email me the problem. What have you asked? And because I am not finding out the formula actually, so that will be easy for me to
Okay.
explain it to you. So you can just mail me of your query, and then I will get back to you and I will answer your query. Okay.
Okay.
I
Okay.
have
Thank
put
you.
my mail ID in the chat box.
Okay. Thank you.
Okay. This is our worksheet problems has done. I have prepared some practice problem with to practice some of the problems that you have encountered in the worksheet. This is your first problem. I
Can you please show problem 10 to and thank you, ma'am.
this is your problem of today's class. You approach this problem. I am giving you 4 minutes to solve this problem, and then I will get back to you and discuss with you.
Answer is 3.05, ma'am, into 10 to the power minus 1. Options not there.
The answer of 1, no, it's coming 7.76 into 10 to the power minus 8. Check your calculation. Check the plus minus sign, because in thermodynamics that is a very crucial step. Once check the plus minus sign, or else I also do a mistake, so let's solve it. Yes, option A is the correct answer. Very good. Option A is the correct answer. Now I am solving it for you. So it is delta G equals to delta H minus T delta S. So minus RT ln n, sorry, uh, delta H is minus 72 kilojoule, so it should be in joule, 10 to the power 3. R should be in joule, 8.314, and T will be your Kelvin scale. So the quick graph, this will be 3 333. So here is 333 minus delta S is minus 80 divided by R is 8.314. So, oh, here is ln. It becomes ln me is equals to minus 26, 26.23 minus minus of 10.82. Minus this will be 15. It will become 2. Oh, sorry. Here is it. Sorry. is equal answer. Now going to the next problem. This is the next problem for you. You solve it. I am giving you 4 to 5 minutes time to solve this problem. Okay?
Ma'am, ma'am, can you please show previous slide, ma'am?
same problem, uh, same like problem. Delta G is equals to delta H minus T delta S. So delta G means minus RT in E delta H T delta S. Sorry. Um, delta H is your R will be 8.314 and your T in Kelvin will be 298 minus delta S will be minus 90 and R is equals to 0.314. This will give you an answer. A1 is equals to 26.23. Minus of 10.82. This will become this will give you power minus 7. This is the answer. Now I am moving forward to the next one.
Ma'am, can you please show previous slide, ma'am? Previous one. First problem. Okay, ma'am.
So problem number 2.
Thank you, ma'am.
Problem number 2, that is consider a thermally initiated radical polymerization with no chain transfer reaction and termination, only via bimolecular reaction between propagation reaction. That is transfer reaction with no chain transfer reaction and termination only via bimolecular reaction between the propagating radicals. So what does it means? Bimolecular reaction, that is, C, it is a propagating radical, C, it is another propagating radical, then by the combination of this bimolecular combination or coupling, whatever you say, this forms this. No disproportionation happen. At the end of the reaction, the polymer produced has an average number of initiator fragments. Number of initiator fragments per molecule is 1.30. So here it is your what is the percentage of the chains that are terminated by coupling? You try it, then I will solve it to you. So try it, 2 minutes I am giving you. No, 47% is not the correct answer. Okay. Okay. Produce average number of initiator fragments per polymer molecule, that is, it is the B. We have to calculate, B is here 1.30. We have to calculate A, that are the percentage of polymer that has terminated by coupling reaction. So we have B is equals to 2 by 2 minus A. Here we have B is equals to 1.30. This becomes 2 by 2 minus of A. This will give you 2.6 minus 1.3A is equals to 2. 2.6 minus 2 equals to 1.3A. This is 0.6, 1.3A. Equals to 0.6 by 1.3. I think your answer is correct. I have done some mistake in my calculation. No, it is coming 5 by 3. Yes, it is coming near about 40. 0.46, and it will be near about 46%. I think I have done a mistake here. Oh, sorry. Here is 1.30. No, it's fine. It's fine. It is 1.30. Okay. So I'm moving forward to the next one. Uh, this is a similar problem like this. You can solve it quickly. You just solve it. Then I will move towards the second problem. I'm giving you just 1 or 2 minutes to solve it. I'm solving it. Here also initiator fragments per molecule, that is B. B is equals to 1.80, and you have to find out A is what we all know. Yes, 88.9 is the correct answer. We all know that B equals to 2 by 2 minus A, and by putting 1.80 here and by solving this, we'll get 8 equals to near about 89%. 88.5 is also correct. 88.5 is also correct answer. So next one. So this is your next problem. Quickly read the problem. Styrene is polymerized by thermally initiated free radical mechanism at 65 degrees centigrade. The initial monomer and initiator concentration is this and this. At the polymerization temperature, the initiator efficiency is 0.80. The rate constant at this temperature are given below. Assuming the initiator consumption is negligible over the first 1 hour, that is, you have to assume here I equals to I0. Here is clearly mentioned that you have to consider I equals to I0. If steady state of free radical concentration after 1 hour, then you have to find out X. If this is written, assuming initiator consumption is negligible over first 1 hour, that means you should take I equals to I0. Okay, because it is negligible, we are considering it negligible for the first 1 hour, that so that we can consider it I equals to I0. So let's move to the problem. Okay, I have to give you time, 2 minutes to solve it. trying to say 2.82. Answer will be x. So the value of x is 2 actually. So let's solve it. Okay, we know the monomer concentration, monomer radical concentration is equals to root over of Ri by 2 Kt. Now we have to first calculate Ri. Ri is equals to 2F Kd I. So here 2 0.80 Kd is 5 into 10 to the power minus 5 and I is 0.001. Here it is written. Okay. So this will becomes, let me calculate, it will come in 8 into 10 to the power minus 8. So now we know the Kt value. We have the Kt value. Now to just quickly calculate m dot. So Ri by so it will become 2 into 10 to the power minus 8. So the value of x is 2. So next we are moving to the next topic, that is kinetic chain length of a thermal initiation radical polymerization. Kinetic chain length, which is designated as Rp by Ri, and in steady state approximation we know that the value of Ri and Rt will be the same. So we can say that nu equals to Rp by Rt also. So then it becomes the Rp by Rt becomes Kp into m divided by 2 Kt m dot. This formula reduces to this. So our main formula for nu for our main formula will be Rp by Ri or Rt, whichever preferred, and Kpm divided by 2 Kt m naught. Okay, this is our formula for kinetic chain length. And now we have the formula for m naught, we have the formula for Ri. So as necessary we will put it up, and by simplification, by putting all the values of m dot I dot, the formula is coming like this for thermal initiation reaction. But you don't have to remember this formula, you just remember this formula or Rp by Ri, or this will be sufficient for solve the problems. So for the thermal initiation radical polymerization reaction, the termination can be of two types. One is coupling or combination, another is disproportionation. So if it is by coupling or combination reaction, so then Xn is equals to 2 nu. That is the two molecules joined here for forming one. They see here it's m plus n, so here is 2 nu, two molecules are joining. And if the disproportionation occurs, then the number of molecule is not changing, so Xn will be the nu. And then the formula Xn is equals to B nu is equals to 2 nu by 2 minus A. This is our formula. I am the derivation of this formula is not showing in your lectures. So what is A and B here? A is the fraction of propagating chains undergo termination by exclusively coupling, not disproportionation, exclusively coupling. And B will be the average number of initiator fragments per polymer molecule. Average number of initiator fragments per polymer molecules. So in per polymer molecule, the average number of initiator fragments, this is B, average number of initiator fragments per polymer molecule. So we can say that average number of initiator fragments per polymer molecule will be of value 1 to 2. Why this is so? Because for coupling or combination reaction, we have two initiator molecules in each polymer chain. This is the maximum possibility, that is 2. The value of B is 2 initiator molecules. If it happens disproportionation, like by the dead polymer, if disproportionation happen, then the initiator per chain initiator molecule will be 1. Then now they are showing that the average number of initiator fragments. So in a reaction, not 100% will be the coupling reaction, not 100% will be the disproportionation reaction. There will be a mixed of two reaction. So say if 100 molecules has coupling reaction and 50 molecules of disproportionation reaction, then they will do it just average 100 into 2 plus 50 into 1 divided by 150. Like this, they are calculating the value of B, the average number of initiator fragments per molecule, per polymer molecule. Is it clear that one who asked the questions on B and A? Okay, I think she is not here. Okay.
Yeah. Thank you. Yeah.
Okay, okay,
Mm, no.
okay. So this is the entire case, and I have prepared some problems regarding these formulas, because regarding these formulas, problems are not there in your weekly worksheet. So I have prepared some problem with this so that you can habituate how to approach this kind of problem. So this is the main problem. This is a long one. I think this will be the our this class last problem. So this is the kinetic chain length. Okay, just a minute. Yes. So at 70 degrees centigrade, Kd is given, Kp given, Kt also given, F is also given, Mi, all things are given. You have to calculate the m dot, nu, kinetic chain length, degree of polymerization, and degree of polymerization. Just consider it all the combination reaction is all occur, no disproportionation occurs, and the number and the number average molecular weight. So let's start with m dot. So let's start with m dot. M dot is very easy. It is root over of Ri by 2 Kt. M dot will be 6 into 10 to the power minus 8 divided by 2 Kt. Kt is 2 into 9 into 10 to the power 7. This will become 1.83 into 10 to the power minus 8. So your m naught value is here. Now we have to calculate kinetic chain length, that is nu. Nu is equals to, I have shown you, Kpm divided by 2 Kt m naught. This is the formula for the kinetic chain length. Now just put it Kp here, Kp, that is Kp, yeah. Kp is 3 into 10 square. Monomer concentration is 1 molar. into Kt is 9 into 10 to the power 7 and m is 1.83 into 10 to the power minus 8. This, by solving this, we will get answer kinetic chain length is 91.3. So if kinetic chain length is 91.3 and we are considering all are the combination reaction, we are considering all are the combination reaction, then the degree of polymerization. If all the combination reaction is happen, then degree of polymerization will be 2 nu, that is 2 into 91.3 will give you 183. It will give you 183. And for number average molecular weight is very simple. Styrene repeat unit is 104. You have to remember the styrene, methyl methacrylate, like this kind of repeat unit you have to remember. In examination they will not supply the repeat unit value. So Mn Xn into MRU is 104, that is it becomes 183 into 104, this will becomes 1.9 into 10 to the power 4. Until now, is it I think, is it clear to all of you how to calculate kinetic chain length and from this degree of polymerization? So you can notice that when okay, when we do disproportionation, then we will notice. Just give me a second. Then the termination, if 100% disproportionation, then also we have to calculate these three values. So let's see if disproportionation occurs, what will be the value of degree of polymerization, how it will affect the degree of polymerization and rather than the molecular weight. And okay, so I don't know why it is not. Okay. So for if 100% disproportionation is occur, 100% disproportionation is occur, disproportionation occurs, then Xn will be nu. So it will be equals to 91.3. So say that if 100% disproportionation occurs, then degree of polymerization is smaller if the combination is occurs. So for combination reactions we get a longer polymer chain and disproportionation reaction we get a comparatively small polymer chain. So here you can see the effect on the Mn value, that is number of average molecular weight, that will be 91.3 into 104 and it will be 9.50 into 10 to the power 3. This will be your answer. So see, 10th order difference we can find in the, if disproportionation happened and if combination happened. So if the next third problem is saying that in a mixed situation what? 40% combination and 60% disproportionation. 40% combination means your A value is 0.4. So 40% combination, A is equals to 0.4. Then what will be the value of the degree of polymerization and molecular weight? So we have to calculate B first. 2 by 2 minus A is equal to 2 by 2 minus 0.4, so in giving you 1.25. Now degree of polymerization when both disproportionation and combination occurs, that will be 2 nu and it becomes 1.25 into 2. This will become sorry Xn become B nu, not 2 nu, B nu. This will become B is 1.25 and nu we have calculated 91.3. So, our xn will be 114 and as for the number average molecular weight will be 114 into 104 is equals to 1.19 10 to the power 4. This will be the 3 cases where only combinations occur, only disproportionation occur and mixed disproportionation and combination mixed occur. And what is the problem 4? Okay, problem 4 is I equals to I0 equals to this. After 2 hours estimate m dot nu and xn. So, we have to calculate first I. For this we have to calculate here, first we have to calculate here I0 to I. Then the rest of the process is exactly the same. Then the rest of the process is exactly the same. So, I am doing this, it will be the last sum today for today. So, we have to first calculate I here. I equals to I naught e to the power minus k dt. This will equals to 10 to the power minus 3 to the power minus 5 into 10 to the power minus 5 into 7200. 2 hours. So, it is in second 7200. I am writing it 2 hour equals to 7200. So, I will be 6.9768. So, for kinetic chain length we need Ri Rp by Ri. So, we have to calculate Ri at time t, that is 2f kt it, 2 into f is 0.6, kd is 5 into 10 to the power minus 5 into it is this 6.9768 into 10 to the power minus 4. So, Ri becomes Ri becomes so your Ri. Now we have to find Rp by Ri. Here we know it is Kpm divided by so we have all the values except m dot. So we have to calculate m dot. M dot will be root over of Ri by 2 kt equals to root over of Ri will be 1.1861 10 to the power minus 8 divided by 2 into kt. Kt is your what you have known now. Now nu is equals to kpm, that is kp is 3 into 10 square into 1 divided by 2 into 9 into 10 to the power 7 into 1.53 into 1 minus 8. Oh, sorry, m naught, sorry, this is not right. M naught is 1.53 into 1 minus 8. Now the nu is 1.9 into 10 to the power 2, that is
Ma'am, ma'am, in the previous slide, how the KT value is 1.53, ma'am. KT value is ma'am 1.53 into 12. But in the question, it is question KT value is 9.0. Into 10 to the power 7, ma'am. 10 to the 7, ma'am. Yes, ma'am.
oh, sorry, 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 minus 8. Okay, so nu is close to 100. uh, xn will be 2 nu is equals to 2 into 1.09 into 10 square plus 2, 219, and mn will be will be 219 into 1004, 2.27 to 10 to the power 4. This will be your mn. So this is the today's last problem.
Please show the previous slide. 1 second, ma'am. 1 second. Yes, ma'am.
Ma'am, ma'am, we are getting mu value 1.9 into 10 power 2, right, ma'am? But in next slide, why are you substitute 1.09 into 10 power 2, ma'am? Okay, ma'am. Nice done. Thank you, ma'am.
Course offered. You can ask me. I will try to get back to you. So you can ask your doubts now. We have 10 minutes of time.
Can you please show us the formulation slides for the numerical point of view, like the formulations you have used? Yeah, and one other slide was also there, I think.
Slide formula. No, today is the only one slide for formulation. That's the only slide.
Okay, okay,
It's only for today's formulations
okay,
and all that.
okay,
You can tell me
okay, okay.
which
Thank you.
formula you are looking for so that I can show you that slide also. It may not be today's. It may be back classes. So you can ask me the formulas.
Okay, actually, I was not looking for the specific formula, but overall formulations, I would like to see, like to have the note,
Okay.
yeah, to prepare note. Yeah.
Ma'am, I
Mm.
think you have NPTEL team has shared a Google slide link to all of with all of you. You can go to that Google slide link. I will update. I am updating all these slides and numericals in that Google slide so that from there you can find it the formula slides.
Okay, okay. For all the weeks, na? For all the weeks, numericals. For all the weeks, numerical.
That we have
Okay,
completed
okay.
week 4. I will update the week 4 slides like
Mm.
by today's second half. I will update all the slides of week 4, and you will get the problems of week 1 to week 4. Now every week I am updating the slides, so you don't have any problem.
Okay, okay. Thank you. Thank you so much.
Anyone else? Yes, ma'am, we got till last class. Actually, okay. uh, Hi, someone is asking Vinny Vagreshri says, ma'am, please share your mail ID. I have already shared with you. Is it showing to all of you in the chat box, or else I will write it again? Just confirm me, is it showing or not? I'm writing.
We can see the text in the chat box, ma'am. Everyone can see.
Sorry, ma'am, I can able to see your mail ID. Could you please share? Thank you, ma'am. Now I can able to see it.
Ma'am, ma'am, can you please go to that curve slide, ma'am? Inhibitor slide, inhibitor retarder. Ma'am, in the third curve, it's this type of curve is shown for the acceleration in that nodes provided, ma'am. So what we have to pick, whether we have to pick the accelerator or inhibitor plus retarder, ma'am. Okay, ma'am. Yes, ma'am. Yes, ma'am. Thank you, ma'am.
If you don't have any queries, you can leave the meeting. It's no problem. I'm just here for to take the questions. If you have queries, otherwise you can leave the meeting.
Ma'am, can you please explain last discussed problem, ma'am? At the end of the lecture, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
One, two, three, or four.
Ma'am, last one, ma'am. Fourth one. Fourth one, ma'am.
Also taking m dot new for calculation of m dot new and xn will be exactly the same, but instead of I0 where we put the I0 value, that is 0.001, we have to put the value. Now we have to put the value of I, which is I0 e to the power minus kd t. T is the time. at at what time you want to measure the I, the initiator concentration. So when they are saying after 2 hours, means after 2 hours some of the initiator is consumed, right? So after 2 hours the m naught nu and xn value, when this polymer will happen, see, the polymerization reaction not like that all the initiator molecules get dissociated and polymerization is all the initiator molecule get attached with the monomer and then polymer. This is not a very straightforward reaction. It is like that initiator has its own dissociation rate. So see, if we start with 100 initiators molecules, then first two initiator molecules decrease and two initiator molecules, for these two initiator molecules all the polymer all the monomer molecules are present. So it has the opportunity to react with all the monomer molecules. But when these two when the third initiator comes, then from the 100 initiator the third initiator comes, it will see some less monomer molecule. Why? Because already these two molecules find some monomer molecules and react with them, other issues are there. So when the third one is coming, then third one faces some lower amount of monomer molecule. For fourth one, gradually further. So going with the time, the initiator molecule finds the monomer molecules is changes, is actually decaying. So it will have when that in when after 2 hours, then the initiator molecules will react with the monomer molecules. They will not give you that high molecular weight or that high chain length. Because why? Because they cannot find the enough number of monomer molecules. So at the end of that, you when new polymer molecules are formed, you will get some lesser value of the chain length for which initiator is attacking. By at the same time, also in this reaction, termination is happening, disproportionation is happening, combination is happening. So we just forgot each and everything. We just forgot the termination. If we discuss with initiation and propagation, then after with time, the initiator molecules finds the monomer molecules will be less. So it will affect the degree of polymerization and the other things. Now it is clear.
Yes, ma'am. Thank you, ma'am. Ma'am, can you show that slide, ma'am? Fourth question, ma'am. Okay, ma'am. Thank you, ma'am.
Uh, if you have any queries, you can ask me in my mail ID. Okay. Thank you. Thank you for all for attending the class. Thank you.
Thank you.